So, we start today our last leg of this course, and the topic is digital electronics. The kind of circuits, the kind of devices, the kind of units we had been talking so far, be it an oscillator or an amplifier or a p-n junction diode used as a LED or photodetectors or solar cells. In all these, we had been talking of voltages and currents, and these voltages and these currents could vary in a continuous fashion. That means the signals that we were applying, those signals were also in terms of voltages, and they were varying continuously as a function of time. They could take various values which could change from one end to the other end, similarly for output and all those things. And each value has a significance, each value. So, if the voltage changes from 3.56 to 3.58 or 4.12, 4.12 has a different meaning and 3.58 has a different meaning. For example, I am speaking and the sound is being converted into voltage signal by the microphone. Now, as I am changing my intensity of sound, the voltage signal is also changing, the voltage is also changing in that output waveform, and it is very important. Each value of the voltage corresponds to a particular value of the intensity that I am producing in sound, and therefore, as I speak, the similar thing has to be reproduced by the microphone and the amplifiers. So, each value is significant. Now, in digital electronics, we set ranges, two ranges. One range is say 0 to let us say 1 volt, and anything in this range, any voltage in this range, 0.1 or 0.2 or 0.15 or 0.37, if I set the range as 0 to 1 volt, then any volt which is there in this range will have the same significance. So, I club all these things together and say that the voltage is low, LOW, low. So, it is just one unit, low voltage. Low voltage could be 0, low voltage could be 0.1 or 0.16 or 0.32 or 0.57 if I have set the range as 0 to 1. Anything between 0 to 1 volt is clubbed. Similarly, I can set another range 2 volts onwards, 2 to 4 volts or 2 to 5 volts. So, anything between that 2.1 or 3.1 or 4.1 or 2.7 or 2.8, all these voltages are treated as one single volt, one single unit, and we call it high. So, we have low voltage and high voltage, just two. Now, you must wonder that are we not putting too much restriction on ourselves? Are we not losing information? In the previous case where the voltage could change continuously, each voltage, each single voltage has some information in it. And now I am saying that 3.7 and 4.1 is same, to 3.8 is same. Are we not losing information? Yes, we are losing information, but then there are cases in which we do not need that information that we have lost, and if we do not need that, and if we can design our electronics which is specifically meant for the things that we are needing, that will be much more efficient. So, that is how the digital electronics has become very, very powerful tool in varieties of information processes, and the one in which the voltages and the currents were changing in a continuous fashion, that is known as analog signals, analog circuits or analog electronics. So, analog and digital, these are the two major divisions in electronics. So, I give you an example. Suppose I have a factory, and in that factory I have some plant in which some boiler and some units are there, and let us just concentrate on two factors, pressure and temperature. So, something is going on, some reactions are going on, something is boiling and all those things. Now, if the temperature is above a certain pre-specified value, suppose 370 degrees Celsius. So, I know that if the temperature is generally in the range 300 to 350 and so on, but if it exceeds 370 Celsius, then it is dangerous, and therefore, the plant should be shut down. Similarly, pressure, there is some predefined pressure, 20 atmospheric pressure, 15 atmosphere, some predefined pressure. If the pressure goes above that, then there is danger and it should be shut down, and I have to design a circuit to see that pressure does not exceed 370, this temperature does not exceed 370 degrees Celsius, and pressure does not exceed that 15 atmospheric pressure, and if they do, then the plant should be shut down. So, let me write it. Suppose I have this unit here, this is our unit, and in this unit we have some pressure and we have some temperature, and some things are going on, some processing is going on, and pressure is building and temperature is building, and at in a steady state there should be some fixed pressure and temperature which could vary little bit, but this P should not go beyond, P should be less than P naught, and this T should be less than T naught or equal to. It should not exceed that. If it exceeds, then there should be a signal which says that shut down this plant here itself. Okay. So, what we can do is we can have sensors, we can have a temperature sensor. So, this is another unit, this is say temperature sensor. What it does? It creates a voltage. It creates a voltage corresponding to the temperature. Different temperatures will create different voltages, like thermocouple. Okay. In thermocouple, what you have? In thermocouple, you have two different wires of different materials, 1 and 2, and then you have a junction here, and then this junction you can, this is a temperature sensor, and whatever is temperature here at this junction, corresponding to that, it creates a voltage here. It creates a voltage between these two ends that you can measure, and from there you can know what is the temperature. Okay. So, this is a sensor, this is a temperature sensor, it senses the temperature and creates a voltage according to that. More the temperature, higher is the voltage created, and vice versa. So, this is an analog, this is an analog circuit, this is an analog sensor. It creates a voltage which is which can continuously vary. The temperature can continuously vary and the voltage can continuously vary, and each value of this voltage is significant. Each value of this voltage is telling me what is the temperature at that instant. So, this is this gives me voltage. This gives me a voltage, let us say Vt, a signal, a voltage signal here, of course analog. Similarly, for pressure we can have a pressure sensor, we can have a pressure sensor here, and then this pressure sensor gives another voltage here. Now, there are circuits called comparators. So, this comparator circuit, what it does is, this is called comparator. This comparator circuit has some predefined voltage set, and this input voltage which is coming from the sensor, if that is greater than this predefined voltage, This is the predefined voltage or preset voltage in the comparator circuit. Comparator is a circuit in fact. So, if this input voltage which is coming, if that is greater than this, it gives me an output which is which has a high value and a fixed value, of course, let us say 3 volts. So, it gives me a 3 volt value which I will call high. And if this V is less than V naught, then it will give me a low voltage, a 0 voltage or some 0.1, 0.2 voltage. So, that is low. So, it can give me high, it can give me low, depending on how much is this voltage here. If it is more than this V naught, and this V naught I can set corresponding to that limit T naught. Suppose 370 degrees Celsius. So, I know at 370 degrees Celsius how much will be the voltage created here. So, I can put that as the preset value. So, once this signal, the moment this signal is more than that, it gives me this high output, and as long as it is less, it gives me the low output. So, this is it. Similarly, you can have a comparator here. Similarly, you can have a comparator here. And for pressure also I can set a value, preset value. If it can withstand 15 atmospheric pressure, for 15 atmospheric pressure, how much will be the voltage? So, that I can preset here, and the moment this voltage coming, this is the input of this comparator. If it is more than that, it gives me high, otherwise it gives me low. Now, I have two signals, I have two voltages. Now, I have two voltages which can be either high or low. Each of this can be 0 or around 0, or say 3 volts or around 3 volts. So, once I have these two signals, now I should have a circuit which can process these, which can tell that okay, if any one of them is high, then a signal is created which gives me an instruction to shut down the plant. So, I need a circuit here, and this is that digital circuit I am talking of. This is that digital circuit which takes digital signals, and which gives me an output, digital output. So, that is the digital circuit. It takes digital input. Digital input means the input voltage is not continuously varying, and it does not have to analyze them value by value. It is coming either low or high, and then it gives me an output which is also either low or high, and from this I process. Now, I am not losing any information. I need to know when to shut down this plant, when the pressure is exceeding, when the temperature is exceeding, when this danger alarm has to ring. For that, it is perfect. I am not losing any information. It is doing its job. So, this is how that digital circuits are made, which can take several outputs, 1 output, 2 output, 3 output, which can take several inputs, 1 input, 2 input, 3 input, and so on, and all in digital form. That means the voltages which are going in this circuit on the input side, they are either high voltage or low voltage, 0 or whatever I said, 3 volts. 0 or 3 volts, and if there is some variation over that, if it is 3.05 or 3.07 or 2.9, whatever, little bit variation, this circuit knows that okay, this is high and this is low, and then according to the need, there may be several outputs also, and they are also in the digital form. So, that is the meaning of digital electronics. Another very important area where this digital electronics is needed is our arithmetic calculations or processing of information. All our calculators, all our computers, they work on these binary number processing. Our calculators, we multiply things, we divide things, we do all kinds of calculations. In computer also there is a lot of calculations involved. So all these need binary numbers. All the mathematics, all the arithmetic is done in terms of digits, and these digits are digital. Digits, even if it is 4.7, I have digit 4 and 7, this is digital. So entire mathematics is done with that, and digital circuits are needed to process all these mathematics, all this arithmetic in calculators and computers and these devices. So I will be talking a little bit of this arithmetic also, because slightly different. It is binary arithmetic or binary calculations. We use our decimal systems, instead computers and calculators use binary system 0 and 1. So let me talk a little bit about that. So in the decimal system you have 10 symbols to use, and of course India has the credit to invent this system, which is so widely used, and the symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 10 symbols on which this entire arithmetic is done. And if I count things, that is how the first lesson in arithmetic is given, counting things. So you remember your textbook of mathematics of class 1 or nursery or KG, where you have some pictures where one flower is there, and then this symbol 1 is written, then 2 flowers are there, and then the symbol 2 is written, and so on. So these are used for counting. And you add 1 by 1 flowers, and then you have to start with, you don't have any flower, call it 0, and then 1 flower, you add 1 more, you say now you have 2 flowers, add 1 more, you say you have 3 flowers, and so on. Once you have 9 flowers and you add 1 more, the next number, add 1 more means you are going to the next number, and for that you don't have a symbol, and therefore you use 2 digits, 2 of these symbols, and those 2 symbols are 1 and 0. So this is the smallest 2 digit number, and then you keep adding 1, 1, 1, 1, and you reach 19, and then you add 1 more, still with 2 digits, 2 symbols, 2 of these 10 you can manage. Once you have 1 more, then you say that all right, here all it was 1, here it was all 1, and then you have exhausted your symbols. Once you exhaust your symbols, you say that okay, now at this place I change the symbol, this 1 becomes 2, and then you start 2, and then this 2 remains here, and then this digit called unit digit, that keeps changing, you increase that. So with these 10 symbols you write so many 2 digit things and so on till you reach 99, till you reach 99. Okay, 91, 92, 93, 94, 95, 96 and 97, and now you have exhausted all your digits. So with 2 digits you can only make these numbers, and if you have gotten that maximum and maximum 9 and 9, now you need 3 digits. And how do you start? You put 1 0 0. Once the digits change, 2 digit, this is 2 digit, you start with 1 0, 3 digit you start with 1 0 0, and then you change this number here, 1 0 1, 1 0 2, and so on. So this is how the counting goes. Now if I don't use 10 symbols, use only 2 symbols, that is the binary number system. And that also, the first written use of this binary system, that also goes, the credit goes to an Indian person called Pingla, way back in some 2nd century BC or somewhere in those times. He actually invented this system, he used this system, but not for making calculations, not for doing arithmetic, mathematics. It was a totally different area, and that was to organize those chandas and those verses in a proper order according to the meters, the number of syllables which are there, and so on. So, in his book Chand Shastra, he describes how these 2 symbols, small and big, can be used, and how the decimal number can be converted into this system, and this binary number can be converted back into the decimal system, and those things have been done. So, in binary number system I have only 2 symbols, that is the difference. We have this was our decimal system, and let me do binary. So, this was counting in decimal systems, and if I do counting in a binary system, think of the first book of arithmetic, counting, but using only 2-digit symbols. So, how will it go? If you have one flower, you will make a picture of flower, and then you will say it's 1. If you don't have any flower, you will call it 0. But what if I add one more flower? Then I have to go for the next number. I do not have next symbol, so I have to go for 2-digit number, and when I go to 2-digit number, what I do? I am to use only these 2, and that will be 1 0, like this. And if I add one more, if I add one more flower here, then what do? I have to increase this number by 1, and as I did here, from 1 0 I went to 1 1, here also I will go to 1 1. And that is the maximum in 2 digits I can do. So, if I add one more flower in this bunch, I have to go to the next number, but next number has to be a 3-digit number, and the smallest 3-digit number I have to write, and we will write that 1 0 0. So, this is how it will go. You increase 1 by 1. So, this will be 1 0 1, the next will be 1 1 0, and the next will be 1 1 1. I have reached the maximum 3 digits number that I can. Next number you add one more, and it has to be a 4-digit number, and that 4-digit number will be 1 0 0, like that. So, the place value system is still there. You have that unit place, and not tens place, this will be 2's place, and then this will be 2 squares place, and this will be 2 cube place, and so on. So, you can have that conversion, that numbers. So, if I write, suppose let me write a sentence. Yesterday I purchased, let us say 1001 oranges. At 101 oranges in the morning. And the rest in the evening. Okay. So, if it is decimal system, I must be some kind of a Superman or a divine person like that. I can do whatever I like. But if it is binary system, it is very natural for us. Place value. So, this is 1, this is 2, this is 2 square, this is 2 cube. So, if I talk in decimal, the equivalence is this is 8 and this is 1, 9. I purchased 9 oranges, perfectly all right, normal. And then I ate 101 oranges. So, this is 1, this is 2, this is 2 square. So, 1 here and 4 here. So, I ate 5 of them here, and the rest is how many? What is rest? The rest is 100. 1 place, 2's place, 2 squares place. So, this is 4, decimal 4, right. So, this is how the binary number system goes. And then the first thing after counting, what you learn in your textbook of nursery, KG or class 1, that is addition. So, we will talk about addition. So, let us take these numbers, let us say 4, 7, 5, 6, then let us write 7 here, 3 here, some 8 here, 2 here. We have to add any two numbers to be added. What is the basic rules I should know? The basic rule that I should know is how to add two one-digit numbers. So, I have here 6, I start from the right side, 6 plus 7. So, I should know what is 6 plus 7. And when I say it is 1, 3, I am using two symbols, 1 and 3, and this I call sum and this I call carry. So, if you think this as some kind of a processing unit, it is taking two inputs, two one-digit numbers, and it is giving me two outputs. One is this unit place and one is this tens place, and we say sum and carry. Sum we write here and this carry we write here. Then it is 1 plus 5. I have to do this 1 plus 5. 1 plus 5. And that is 6. So, essentially here also you have this is the sum and this is the carry. And then this thing is to be added in this. So, the sum has to be directly added here and the carry has to go somewhere else, but here the carry is 0. So, our life is simple. So, that 6 is to be added here, and once again 6 plus 3 is 9, 0, 9, sum is 9 and carry is 0. So, that 9, that sum comes here and the carry goes here. Once again 0 plus 7. So, you can see at every step I need to know what is that one digit number plus one digit number, and that again gives me 0, 7. So, the sum is 7 and the carry is 0. So, that sum is to be added here, the carry is to be added next to this number which is not here. So, that is it, and therefore, this 7 plus 8, and that 7a plus 8 is 15. So, this is the sum, this is the carry, and so sum I will write here and the carry I will write here. Then once again 1 plus 4 and same story, then 5 plus 2, same story, 7, and the process ends. Okay. So, essentially to do addition of any numbers, however long the number may be, I need the addition of two one-digit numbers, and the same holds for binary number system also. In decimal I had 10 symbols, and then you have so many combinations of these digits. Here it is 2 numbers, so those combinations will be much less, but we have to essentially do these things. So, we will do this in the next lecture and see how a circuit can be designed for that.